don't know if any of them have lead. Okay. All right, so scale drawings and models. When we're talking about this, like a scale drawing would be like just a drawing of a horse that's smaller or a map. An actual model, we're talking about like a 3D model, okay? So like a sculpture. Down in the cities, there is a huge sculpture of a spoon, right, with the cherry? Yeah. That's a model because it's 3D. You could actually like grab it and touch it, okay? Or we could talk about a model as like a little toy car. A toy car is a 3D model of a real car, okay? But a drawing is just a picture of it, just either bigger or smaller. Okay, so a scale drawing or model is a way, a way to show something accurately that is much bigger or smaller. Using proportions. Kind of a long definition, sorry. I did shorten it from last period, though. Crushing it. Okay, so a way to show something accurately that is much bigger or much smaller using proportions. So to make sure that it actually looks like the thing that we're trying to make it look like, we have to use proportions. We have to make sure that when we draw a horse, the amount, how tall it is, the height of it, matches the width of it, or how long it is. Okay? So we talked about things that were much bigger, like Apollo. We drew a map of Apollo. That's something that's bigger that we made smaller. Can anyone think of small that we would want to enlarge to make big, to make a model or a drawing of? What? A bean? Sure. If you studied agriculture and you wanted to know like the parts of a seed in a bean, sure, you'd make it bigger. What's else something that like right now you might be learning about in biology that you're making bigger? Atoms, right? You guys are learning about protons and neutrons?
We're learning about
Moles. Okay. I just hear Miss Johnson talk about protons and electrons and stuff. No? Am I nuts? You're learning about moles. Ooh, I don't know. I'm just making things up now. Okay, but like bacteria or cells, mitochondria, you might want those to be blown up into a bigger scale so we can actually look at it or touch it and be able to discover it. Okay, so 2 words that we're going to need to know for our work today. One is scale. And a scale is a ratio of measurements and when we do our ratio of measurements, we're going to do it to the drawing or the model compared to what it's like in real life. And today when we do our ratio, we're going to be using a colon. So when we do scale drawings and models, we use that colon instead of the fraction or instead of that word 2. So that's one thing. And then this is really similar to a scale, is a scale factor. But we have that word factor, which tells us something more specific. And a scale factor is a ratio of measurements in the same unit, or in the same units. So a scale factor, we're comparing inches to inches or miles to miles. In the scale, we could compare inches to miles. We can go from different things that don't compare exactly, but a scale factor, we actually want to know from inches to inches exactly how much is it. Kind of a lot of writing today, sorry. All right, we're just going to do 2 examples today. All right, our first example, we're going to think about a toy plane. Okay, we know that a toy plane is 4 inches long. All right, and the actual plane that it's made out of, it's trying to represent, the one in real life, is 38 feet long. So the toy is obviously not as long as the actual plane. Otherwise it wouldn't be a toy. We don't play with actual planes, right? Okay, so the toy is only 4 inches long, but the plane is 38 feet long. So we're going to do 2 things with this. We're going to find the scale, and then we're going to find the scale factor. So first, let's find the scale. Okay, so for the scale we're going to compare the drawing or the model to the real life thing. So we don't need to worry about units in a scale, but we do have to label it when we put it in the scale. So how much is the model? How long is it? 4 inches. And we're going to compare 4 inches to how many feet? To 38 feet. So when we say scale, it's okay to have 1 in inches and 1 in feet. But we do need to simplify this scale. And simplify means just like how we did with fractions. If I have 4 over 38, what could I divide both 4 and 38 by? I don't think I can do 38 divided by 4. I think 2. Okay, but if simplifying is not your jam, that's okay. You can use your Desmos calculator. Okay, so in Desmos, we can put in as a fraction 4 over 38. It's because it's 4 to 38, and then I'm going to re-hit that fraction button, and it's going to make it 2 over 19. So it's going to go 2 inches to 19 feet. Even though it's simplified, those labels stay the same. Okay, so again, all I did in Desmos was I put the 4 over 38, and then you get a decimal, so I hit that little fraction button, and we get 2 over 19. Okay. All right, so that's the scale. We're now going to do the scale factor. So for the scale factor, we need them to both be either in inches or in feet. If we wanted to, we could make them both in miles. That'd be crazy. Okay? We're going to convert them at 2 feet. So we're going to make 38 feet. And our question is, how many inches is 38 feet? So we need to know how many inches are in 1 foot. How many inches are in 1 foot? 12. If that's not something you know, you might want to highlight this or box this. You're going to use this on your homework today. 1 foot is 12 inches. So we're going to convert the 38 feet into inches. So we're going to do 38 times 12. And we got the 12 because for every 1 foot, there's 12 inches. And there's 38 feet. So 38 times 12, we get 456. So now we have it in inches. Do we know the model in inches? Yeah, so we're ready to go. We're going to do the drawing first, the model first, and then the real life. So how long is the model for compared to how long is it in real life? We know it's 38 feet in real life, but how many inches? 456. And we could just put inches one time because we know both are inches. Can I simplify 4 to 456? Probably. They're both even numbers, so we know for sure we could divide them both by 2. Do you think we could maybe divide both of them by 4?
We're not sure, we can always find out.
And how would we find out, Miss Euler?
So if we want to know if they're both divisible by 4, what can we do? Yeah, I would just open up a calculator, probably Desmos, because it sets it up like a fraction, makes it easy for us, and see if I can divide it by 4. Can you divide 4 by 4? Yeah, what's 4 divided by 4? 1. And so you just have to check the other one, 456. We can divide by 4. What is 456 divided by 4? 114.
So that's that simplified ratio. So on your practice work today, it's going to talk about an original ratio and a simplified ratio. Original is just the numbers that are given in the problem or the number that you found in inches. And then simplified means that you took that time to simplify it. And in this case, we divided it by 4. Another way, if you didn't know we could divide by 4, if you're looking at this, you're like, I don't know if I can simplify it. You're just going to put in 4 over 456, hit that fraction button, and that will tell you 1 to 114. Okay? We're separating it out instead of a fraction with that colon. Okay, but what's really important with that scale factor today is in a scale factor, you need to know today that 1 foot is 12 inches long. So if you need to write that down, make sure you have that written down. 1 foot is 12 inches. You'll need to know that during your practice today. All right, one more problem, and then you have the rest of the time for practice. Number 2, this one's kind of a lot of writing to set it up. I apologize. I don't know. Okay, a map has a scale of 1 inch to 20 miles. So I use that little colon to show that ratio. 1 inch to 20 miles. A road on the map is 9 inches long. I want to know how many miles is that road long. How many miles long is the road? Is that right? How many miles long is the road? So I'm going to give you a little bit of time to write that down. So when I do these scale problems, I like to start with a ratio that it's giving me. What ratio does this problem already give me? 1 to 20. Good, so it's 1 to 20. And the 1 represents what? Inches. So my inches are on top. What's on bottom? My miles. So I'm going to keep that in mind when I write my next ratio. And I'm only given one other number. What's my other number I'm given? 9. Is 9 inches or is it 9 miles? 9 inches. So is that going to go on the top part of the ratio or the bottom? In the top, because in the top we had the inches. So that goes across and that stays the same. I have to have 9 on the top. So I'm looking for my question mark, or we could use X, is how many miles is it? So how am I going to solve this proportion? What would I need to do first? What? Yeah, we have to flip it. We have to use the reciprocals. So I'm going to flip 1 and 20. So it's 20 over 1. And if I flip one side, I want to flip the other. That way we have that question mark in the numerator. We always want that question mark on top so that we can undo the dividing. So how do we undo dividing by 9? Multiply by 9.
And so now this should look really familiar. This is really what we've been doing this whole chapter. So great.
So in our calculator, we're going to do 20. We could do divided by 1, but what's 20 divided by 1? It's just 20 times 9. And we get 180. In this one there is, because it's a 1 to 20. We could have just done 9 times 20. But sometimes it doesn't always end up like that. You'll have goofy ratios where it's not always with that unit rate. So we know it's 180 miles. Okay, now a couple people are struggling with how to set this up. So some people did 1 over 20 equals question mark over 9 in the practice today. If we did that, my answer would have been 0.45. If 1 inch is 20 miles and it's 9 inches long, would it make sense that that road is only half a mile long? No. We want to make sure it's bigger. So when you get your answers today for those types of questions, make sure you're just double checking, does that make sense? Is it reasonable that if it's 9 inches long, it should be about 180 miles? Yep, that makes sense to me. Okay, that is it for the notes today. This was 7-7.